Good evening, everyone. As Ryan said, my name is Michael. I'm an academic in the Department of Computer Science, where, among other things, I am the module organizer for the functional programming module in the first year. So I want to thank the exec for giving me this lovely advertising slot. I was thinking about preparing this talk yesterday, and I realized that it's been 10 years since I started university as an undergraduate in 2010, so pretty much exactly 10 years ago. This was me 10 years ago. And back then, I had a number of years of experience programming in imperative programming languages. I started out with a language called Pascal with a P, and then I transitioned to Delphi. I did some C, some C++, some C#. Those were my main languages. And I was also done computing at A level. But I hadn't done any functional programming. I had heard of some things about functional programming that sounded very elitist and ridiculous to me. Things like, purely functional, or other things like that, often related to a programming language called Haskell with an H. I didn't know much about it, but at the time I was quite active on a messaging service similar to Discord at the time called MSN, and I had a friend there from Finland who I'd met on a game development forum. And every single day, we would talk on there, and I would come up with a new joke about functional programming to make fun of it, even though I knew nothing about it. And then later on in 2010, as I said, I started university. I went to Nottingham to do a 3-year BSc in computer science. I actually dug out some old photos, because I thought you'd be able to relate. Here's a photo I took on my very first day in Nottingham when I moved into my accommodation. Still completely unaware of what functional programming is, but I did realize that there was a compulsory first-year module on functional programming, and I was not pleased about it. I went to my personal tutor and I said, I've done programming for a number of years. I think functional programming sounds ridiculous. Is there any way that, even though this is a core module, I could do a different module instead? So naturally, by the end of my 3 years at Nottingham, I wrote a dissertation on a functional programming language, where I implemented a compiler for a functional programming language in a functional programming language. So something clearly went horribly wrong after I asked my personal tutor about functional programming. In fact, after my time at Nottingham, I went on to go to Cambridge to do a PhD in functional programming, which is kind of still in work in progress, don't ask. But after that, I went and joined the department here at Warwick as a senior teaching fellow, and I started teaching the functional programming module initially in the second year, and then after 1 year, we moved it into the first year. So yeah. You might ask, what happened to me? I started off completely ignorant of functional programming and made fun of it all the time. And now I'm here having done years and years and years of functional programming. So what happened is quite obvious. I learned more about it. So let me tell you a little bit about the differences between programming as you may know it, if you've already done some programming, versus what functional programming is. So if you've done any if you've done any programming before, you've probably done something that looks like this. If you haven't, don't worry, you'll be doing this in the first term in CS 118. So I've got a little program here in a C-like language. You might say this is Java. I'm going to show you how this program is executed. So we have the source code for the program on the left, and I have a very simplified representation of the memory on the right, where I have my two variables, x and I, and initially they both have the value 0. And as I start executing my program, I step through it and I manipulate the memory as I go along. So every instruction that I execute on the left is going to modify the values in the memory somehow. So the first line here assigns the value 1 to x. So once we execute that, we can see in our memory x is now 1. Then we have what's called a for loop, where again I'm initializing I to be 1. So if I step through that, I is now 1, and then I perform a check to see if I is less than or equal to 4, which it currently is because it's 1, and that means that I'm going to execute this instruction here, which is in the body of the for loop, which tells me that I want to take the value of x and multiply it by I, and then assign the resulting value to x. So after doing that, x is going to be 1 because 1 times 1 is 1. And then after that, I'm going to carry out this post condition in the for loop, which says increment I by 1. So that takes I to 2. Again, check if I is less than or equal to 4, which it is. I execute the body of the for loop, which now takes x to 2, increment I, check if I is less than or equal to 4, which it is. So again, execute the body of the for loop, takes x to 6, I increment I, check if I is less than or equal to 4, which it still is because it's equal to 4. I execute the body of the for loop, and I end up with x equals 24. So that's how you, then I perform another check to see if I is less than or equal to 4, which it now no longer is because I is 5. So I stop and I'm done with my program. So that's how you might calculate the product of the numbers from 1 through 4 in an imperative programming language. So some of you may be used to this, the others will learn it in term 1. Now, in functional programming, we take a completely different approach to programming. Here, I have defined a function which is going to calculate the product for a list of numbers. And the way I define this function is pretty much in a very mathematical style, where I have two equations which say what I want to do for a given input. So in the first line there, I'm saying if I want to calculate the product of a list that contains a single element that I'm going to refer to as n, then I'll just return that one element n. And on the second line, we have a case for lists that have more than one element, where n is going to be the first element in the list, and ns is going to be the list of all the remaining elements in the list. And in that case, I want to take n and multiply it by the result of calculating the product of all the remaining numbers, so all the numbers in the list, except for the first one. So let's see an example of how this is evaluated. So this is essentially the same thing that we've done in the imperative program before, except now in a functional language. So I'm going to use my product function, and I'm going to apply it to a list of the numbers 1 to 4. This dot dot notation there just means 1 to 4. So I'm really calculating the product of the list of numbers 1, 2, 3, and 4, which then by the second equation that defines product evaluates the following. So as I said, the two equations match different cases. The first equation matches the case where the list only contains one element, but here we have 4 elements. So the second equation applies, where we bind the first element of the list to n, and then the rest of the list, or the tail, is bound to ns. So we end up with 1 in place of n times product of n's, which is all the elements of the list except for the first one. And then we just keep repeating this. So we can now evaluate the product of the list 2, 3, 4, which again uses the second equation, where we end up with 2 times product of 3 and 4. And we just keep carrying on like this until we reach the case where the first equation applies. So in this case, we have only one element in the list. So we just return that one element, like so. And then we end up with an expression that just says 1 times 2 times 3 times 4, and we can just evaluate that using arithmetic. So we end up with the same result as in the imperative program. So you can see they're very different styles, but they allow us to do the same things. So they're just different tools for the same job, effectively. Now, as a slightly more advanced example, here's a function in a functional programming language, and I'm not going to tell you what this does, I'm just going to let you look at it for a couple of seconds, and maybe even without knowing any functional programming and without knowing the language that this is written in, you might be able to figure out what this function does. If you have any ideas, do post in the chat. I'll look at that later, and other people might be able to tell you if it's right or wrong. But I'll look at the chat later as well. I can't currently see it. OK, so let's move on. So this style of programming, as I said, is called functional programming. To compare these different styles in a lovely table, which some of you may have seen if you've watched the cinematic trailer that I uploaded to the Moodle, then the main difference is that imperative programming is based on the idea of mutation of state, where state is the memory of your computer. So as we've seen in the example earlier, every instruction that we executed manipulated the values of the variables. While in functional programming, we're pretty much just doing maths, where we are just starting off with an expression and we are simplifying it as we go along. Imperative programming, you write programs by telling the computer how you want to do something. So this is based on the assumption that the computer is pretty dumb and you have to tell it exactly what to do. While in functional programming, we tell the computer what we want to compute, and the compiler or the computer works out for us how to do it. There's also argument about the order in which statements are executed. We saw that in the imperative example, we sort of went top to bottom, although we jumped back several times. While in functional programming, we just have expressions, and the order in which we evaluate sub-expressions or simplify sub-expressions doesn't really matter all that much. In imperative programming, you use loops, and in functional programming, you use recursion. Those are all concepts that you'll learn about as the year progresses. Now, there are a number of functional programming languages. The one that I teach in functional programming is called Haskell. This is the logo for the language, but there are many others like OCaml here, F#. Some people on the Discord who really like F# for reasons that are completely beyond me. Standard ML, which was one of the first sort of modern functional programming languages. Very few people use this for anything like industry related or practical. It's mainly just a research platform these days. Swift, people may be familiar with Apple's Swift language, that's a functional language. Scala, which is used a lot by ITS for tabular, for example, is written in Scala. So, but like I said, in functional programming, we teach Haskell because Haskell is kind of special among all the functional programming languages that I've shown there, in that it's we call mathematically pure. So all functions that we define in Haskell are pure in the mathematical sense. And it's also what we call lazily evaluated, which means that things only get evaluated when they need to be evaluated. So you might ask, what can you use functional programming for? Well, anything that you can use a general purpose programming language for. As I said, it's just a different tool for roughly the same job. You'll find that some programming problems can be more easily solved with functional programming, while others can be solved more easily with imperative programming. So I'm not going to tell you that functional programming is the solution to all of your problems, but it's a good solution to some problems. So if you are a competent programmer who is competent in both imperative and functional programming, then you'll find it a lot easier to solve many problems. Here's some examples of things done in Haskell. Here's one of my favorite examples I like to show, which is related to something called domain-specific languages. Here's some notes for some music. And together with a student from a few years ago, we built a domain-specific language inside of Haskell, which lets you express music in Haskell, like so. So the code at the bottom there is an equivalent representation of the notes from above, but in Haskell using this domain-specific language. And it's really cool because it does something that you might not expect, which is that it tells you whether your music sounds good or not, based on the rules of classical music. This makes use of some advanced concepts in Haskell's type system that allow you to essentially implement new rules in the compiler that can perform checks on your code. So in this case, to tell you whether the music that you've described would sound good or not. So as I said, this describes music in Haskell. If it doesn't sound good, it does not compile. It's a 30-year project I supervised, and it actually resulted in a conference paper at Haskell 17. You can also make games in Haskell and functional programming language. Here's one called Magic Cookies. This is available on iOS and Android. It's using something called functional reactive programming, which is very cool. It's obviously the same code across different platforms, nothing platform specific. And functional reactive programming allows something cool called time traveling debugging, which is very cool. Some people have built system software in Haskell and functional programming languages. Here's a window manager written in Haskell called Xmonad. If you're on a Linux system, you might want to check that out. Some operating systems like Mirage that's written on Camel, House in Haskell, and so on. There's lots of really cool frameworks for developing web applications, because it's so easy to implement domain-specific languages. I particularly like one called Servant, where you describe a web service as a type and it automatically generates the code for you. And indeed, one of the courseworks for the functional programming module uses this. There's much, much more. Facebook spam filter, for example, is written in Haskell. Lots of financial services, especially investment banks, use it. Standard Chartered, Jane Street, Barclays use it, and so on. It's really good for writing concurrent and parallel programs, which become increasingly important. There are domain-specific languages for describing FPGAs if you were into electronics. For embedded systems, people use it for machine learning. There are quite a number of blockchain startups that use Haskell. People use it for compilers. It's a research platform for new programming language features. If you want the latest and greatest that programming has to offer, functional programming languages have it. Pretty much all programming language research these days takes place related to functional programming. But most importantly, as I said earlier, learning FP makes you a better programmer. And furthermore, functional programming techniques have made their way into what's traditionally viewed as imperative object-oriented languages. So, for example, Java has a bunch of functional programming constructs in it now. So that's my little introduction to functional programming. Let me quickly advertise the modules. Here's one for one. It covers quite a bit. It doesn't assume that you have any previous knowledge in functional programming. So it starts with the very basics, and we work our way all the way to advanced stuff, like what we've seen there with the music example, where you can encode rules in the type system. There are 30 lectures, 3 per week. I'm guessing at this point that they'll all be online. I have some experience with that. Last year, I did a 4th lecture most weeks on Twitch, twitch.tv/FP class. I've got a little clip here from a stream that I did early on last year, which is, of course, what you pay £9,000 a year for, was to see some ducks rotate. So we used a little graphics description language to describe this animation. This is actually part of the, well, not this exact scene, but using this as part of the first lab for the module. Speaking of labs, there's 1 per week, and there's a total of 21 exercise sheets, 1 for every topic in the module. So plenty of stuff to practice with. Another thing that I find quite important and include a lot of in my modules is industry skills. So Adam was saying earlier that a lot of CS modules are quite theoretical, but I do incorporate a good amount of industry relevant skills, particularly related to version control and also to test-driven development. So all the lab exercises and all the courseworks come with extensive tests that you can just run, and they'll tell you whether your solutions for the labs or the coursework are correct or not. So you can easily see how you're progressing. Speaking of the coursework, first coursework, you have to, we have this little game based on grids where you have these sort of Sudoku-like grids, and you have to find a combination of cells that, when enabled, make sure that every row and every column adds up to the target number. That's the first coursework. The second coursework, you build a clone of Scratch. Maybe some of you have done Scratch in school. We have a lovely web-based UI, but you write a Haskell program that, given some representation of the program, gives out the resulting values for the variables like this. Okay, so that's my little advert. I'd be very happy for, oops, sorry, pressed too far. Yes, so I'd be very happy for you to get in touch with me. That's my email address. There's a Slack, which I've seen some of you have already joined. That's been running for a number of years, way before Teams became popular. We have students from most of the previous years on there, including myself, TAs. It's the module web page, but I'm very happy for you to message me on Slack, Teams. I'm also on the Discord. I'm always happy to chat with people about functional programming, Haskell, or the module. Don't be afraid, just send me a message. I do realize we've slightly overrun, so that might be the best way to get hold of me in the interest of time. Yeah. Don't know if we have time for any questions or not.
We'll take, what time is it? Give questions about 5 minutes, I suppose. So if anyone has questions, submit them to the live event Q&A thing, or just, contact Michael in your own time. You mentioned contacting you on Discord. Do you want to give people your Discord username?
Yes, I think it's probably easiest to just post that in a channel somewhere.
Sure. I'll post it on #lobby text. Okay, there we are. Wait, did I post it? Oh, I posted it on the wrong channel. There we are.
Yeah.
Okay. Don't have any questions on the Q&A thing yet. Lobby text is moving a bit quickly. I'll try and pass it. Do you want to answer the question, is FP a cult?
Not a cult.
Not a cult, okay. Okay, so, we do have one question, I think. Okay, I'll publish that.
I see one question on the Q&A there. Someone's asking, before we actually choose our modules, is it possible to get a taste of the FP module? Yes, I think. Normally, the first 2 weeks of every term are open for module registrations. So you'll have your 2-week period coming up starting next week, where you can sign up for optional modules, but you can then change those choices at the beginning of term 2 as well. So if, for example, you don't choose FP now and you want to change your mind later, or you choose FP now and you want to change your mind later, then you can do that in the first 2 weeks of term 2. So in terms of getting a taste, you can quote unquote come to the lectures. Obviously, they're not taking place physically, but the videos or the streams, I am planning to live stream all of my lectures. They will be available to anyone in the university, so you don't even need to register for the module. You can just come along to the lectures. All the current materials for the module, by the way, are on the module website, so you can have a look at what's already there from last year. I usually make changes, hopefully improvements to the module every year, so there might be new content for this year. But yeah, everything that is there from last year is there.
Okay. We have another question in the Q&A event.
Did you find any actual real-life use cases for FP throughout your life? Yes, I have a very large Haskell code base that is used in the department. It's called the Warwick Assessment Automation Tool, or WAT for short. It's used in FP, for example, where once you submit your coursework, it gets downloaded by my system, which then automatically compiles it and runs the tests on it that you would also normally run yourself to make sure that your coursework submission compiles fine on our machines and it passes all the tests. And then it sends you my Warwick notifications to tell you that it was successful, hopefully. So you get immediate feedback once you submit to tell you whether everything worked. You can also access that on the web to see exactly what happened to your submission. There's a build log that you can view. You can view your source code that you've submitted just to get that sort of extra peace of mind. It's also used in a number of other modules now. It has some departmental functionality now as well. That's all written in Haskell. There's several 10Ks worth of Haskell code probably, as well as some TypeScript in the front end. The whole JavaScript world and TypeScript and so on also are heading in the direction of more and more functional programming, as do Java people. So yeah, I've written thousands upon thousands upon thousands of lines of Haskell in my life.
Okay, we've got another question from the Lobby Text channel. Thoughts on data-oriented design?
I don't really have any thoughts, to be completely honest. Yeah, I've had no real exposure to it. It's never been something I've been interested in or done anything with.